The topic of this presentation is the Astronomy Visualization Metadata Standard, or AVM. AVM is a standard that can span both photographic images produced from science data and artwork illustrations. This standard allows individual image files to be cataloged and offered through searchable databases. It's being embraced by a growing number of observatories as a tool to capture and store the contextual information important to their image collections. AVM was proposed by the International Virtual Observatory Alliance and was last updated in 2011. It was developed within the framework of the IAU Virtual Astronomy Multimedia Project. It supports the cross-searching of collections of print-ready and screen-ready astronomical imagery rendered from telescopic observations. It's compatible with the Adobe XMP specification, so the metadata can be embedded within common image formats such as JPEG, TIFF, and PNG. These images can combine data acquired at different wavebands and from different observatories. While the primary intent is to cover data-derived astronomical images, there are broader uses as well. Specifically, the most general subset of this schema is also appropriate for describing artwork and illustrations of astronomical subject matter. This is a list of tags associated with AVM. Also included is the desired format for each tag and the corresponding tag in IPTC, which is the photo metadata standard of the International Press Telecommunications Council. It's widely used by photographers, news agencies, and others to provide data about images. The list also includes which set of tags each name is included in, for example, the core set or the semantic set. This is an example of AVM being used in an XMP file. There are some AVM tags in the middle of the record, including publisher, publisher ID, reference URL, and resource ID. Since AVM is compatible with XMP, this is how its metadata can be directly embedded into image files. The core AVM tags are the minimum key elements needed to identify an image or a resource. These tags are needed to determine the resource's origin, version, and usage restrictions. The tags are creator, creator URL, rights, credit, ID, metadata date, and metadata version. AVM tags are physically stored as strings within an XMP header, but many tags are expected to follow a specific format. Each of the metadata tags has one of several possible formats summarized below. There are some tools available to make the creation of AVM metadata an easier process. The Flexible Image Transport System, or FITS Liberator, is a convenient tool for the creation of publication-ready imagery, and it imports astronomical FITS image files into Photoshop. It can then populate the AVM files during the conversion between FITS data and the image. The web tools that exist for AVM metadata are under development at ESA Hubble. They include an AVM tagging tool, CSV to XMP script, and a subject category generator. These can be found at the Virtual Astronomy Multimedia Project website. AVM uses control vocabularies already in use by the standards it was developed within, including the International Virtual Observatory Alliance, the International Press Telecommunications Council, and the Adobe Extensible Metadata Platform. More specifically, the subject category tag uses the astronomical object taxonomy. The spectral band tag uses values found in the document Resource Metadata for the Virtual Observatory, version 1.1, and additionally, dates are represented in standard ISO 8601 format. AVM uses Adobe XMP to embed metadata directly into image files. The XMP specification describes a widely used method for embedding descriptive metadata within images. XMP tags are stored within the image header of all common image formats and can be read by popular image processing and cataloging packages. The XMP standard is also widely used by photographers and the publication industry. The AVM metadata standard allows for the inclusion of World Coordinate System or WCS tags that fully describe the image location, scale, and orientation in the sky. The advantages of a fully tagged dataset are potentially enormous. They may be located in position-based queries like any full scientific dataset. In addition, it is possible for users to develop software to allow for automatic image registration and alignment, for instance, for automatic inclusion in digital planetarium projections. The screenshot here shows the base tags as well as the full tags for the World Coordinate System. The XMP standard utilizes a number of different namespaces that reference the defining standards for different elements of the metadata. As the metadata standards have expanded over time, newer schemas have always utilized earlier relevant schema for backwards compatibility while adding new terms for increased functionality. AVM has been designed with this philosophy, so its XMP implementation utilizes these prior schemas defined in their namespaces wherever possible. The namespaces consist of a case-sensitive shorthand tag, which appears in the XML markup for the metadata, and a URL reference to the defining standard. Those utilized by AVM are listed below. The intended users of astronomical imagery cover a broad variety of fields: educators, students, journalists, enthusiasts, and scientists. The astronomical education and public outreach community plays a vital role in conveying the results of scientific research to the general public. The use of AVM metadata assists in ensuring that astronomical images are organized and searchable. The Spitzer Space Telescope website is an example of AVM being used online. The image gallery for the Spitzer Space Telescope employs AVM within its content management system, and all the images have AVM tags embedded within them. In the middle is an image of the Cat's Paw Nebula. To the left of the image is the user-friendly display of the metadata, and to the right is general information on the Spitzer Space Telescope's website regarding AVM and other metadata information. To learn more about AVM, click on the link or visit the Virtual Astronomy Multimedia Project's website. Thank you for watching.